Hello friends. So in this video we will learn the numerical based on angles of triangle formulae. So here basically we will be applying the properties of trigonometric functions of angles of triangle and then we will solve this numerical. Now in the question itself it is given that a plus b plus c is equal to pi. So it clearly denotes that this question is from angles of triangle formulae. And we have to prove that cos A minus cos B plus cos C plus 1 whole upon cos A plus cos B plus cos C minus 1 is equal to cot A upon 2 into cot C upon 2. Now to start with the solution, I'll start with the left hand side because the left hand side has maximum number of terms, and by simplifying the left hand side we'll proceed and we'll get the right hand side. So here I'll say LHS is now to solve this left hand side and to get the right hand side we have to first observe what is required on right hand side. So on the right hand side we want angle as A upon 2 and C upon 2, whereas on left hand side the angle is A, B and C. So we have to find out, or we have to make that angle from A, B and C to A by 2 and C by 2. So to convert that we have to apply the trigonometric formulae. Now if you will see the numerator, then here we have term cos A minus cos B, where we can apply the formula of factorization. Similarly in the denominator for cos A plus cos B we'll apply the factorization formula. Now if you will see the next two terms of the numerator, then we have cos C plus 1. So you must be remembered the formula of 1 plus cos C, and similarly in the denominator we will apply the formula of 1 minus cos C. So let's apply all the formulae and get the value, and for that we have to adjust the denominator. So here I'll say it is cos A minus cos B in one bracket plus 1 plus cos C in another bracket whole upon cos A plus cos B, and from last two terms I'll take negative sign outside, so 1 will be positive and cos C will be negative. Now what is formula of cos A minus cos B and cos A plus cos B? So guys, remember you have to memorize all the formulae to solve the problems of trigonometry. So I'll tell you the formula for cos A minus cos B. So it is minus 2 times sine of A plus B upon 2 into sine of A minus B upon 2. Here similarly for 1 plus cos C we know that it is 2 times cos square C by 2. Here 2 times sine square C by 2, and for cos A plus cos B we will apply the formula of factorization. So here I'll write it is 2 times cos square C by 2. Here 2 times cos of A plus B upon 2 into cos of A minus B whole upon 2 minus this is 2 times sine square C by 2. Now by applying this formula we have converted this question into the angles of A by 2, B by 2 and C by 2, that is half angles. Now from numerator and denominator I can take 2 common and it will be cancelled. So here we will get minus of sine A upon 2 plus B upon 2 into sine of A upon 2 minus B upon 2 plus cos square C upon 2. whole divided by, here 2 and 2 cancelled with the numerators 2. So cos of a upon 2 plus b upon 2 into cos of a upon 2 minus b upon 2 minus sine square of c upon 2. Now, to get the answer as cot a by 2 into cot c by 2, we'll convert this value of sine a by 2 plus b by 2 in terms of c by 2. And for that, we will use the half, and for that, we will use the formula of angles of triangle. So, we'll say here, in any triangle ABC, we know that A plus B plus C is equal to pi. Now we want the value of A by 2 plus B by 2. So I'll divide both sides with 2. So here I'll say A by 2 plus B by 2 plus C by 2 is pi by 2. And therefore A upon 2 plus B upon 2 is equal to pi by 2 minus C by 2. Now as I want sine of this A by 2 plus B by 2, I'll apply sine on both sides. So here I'll say sine of A by 2 plus B by 2 is sine of pi by 2 minus C by 2. And sine of pi by 2 minus C by 2 is cos of C by 2. So here we got the value for this. Now let's find out the value of cos of A by 2 plus B by 2. And for that I'll apply cos on both sides. So here we'll get cos of A by 2 plus B by 2 is equal to cos of pi by 2 minus C by 2, and this cos of pi by 2 minus theta is sine theta. So here we will get sine of C by 2. So guys, we'll use this substitution and we'll substitute in the numerator as well as in the denominator. So this sine A by 2 plus B by 2 is cos C by 2. So is equal to minus of cos of C by 2 into sine of A by 2 minus B by 2 plus now let's come to the denominator. So here cos A by 2 plus B by 2 is sine C by 2. Let's substitute here and let's keep the remaining term as it is. So we will get now from the numerator we can take cos C by 2 common, and from denominator we can take sine C by 2 common. So we here will get cos C by 2. In the bracket here we'll get cos C by 2, that is a positive term, and here negative sine of A by 2 minus B by 2. Similarly, in the denominator I can take sine C by 2 common, and in the bracket we will get positive term, that is cos of A by 2 minus B by 2 minus this term would be sine C by 2. Now this will give us cos C by 2 upon sine C by 2, that is cot of C by 2. So we got one term of right hand side. Now we want other term on right hand side as cot A by 2. Now the question is how to get cot A by 2 from these two brackets. So it's very simple. Let's convert everything in terms of A and B, or that is A upon 2 and B upon 2, and then apply the formula of trigonometry to get cot A upon 2. So here we can see that we have cos C by 2 term and sine C by 2 term. So I'll convert this C by 2 terms in terms of A by 2 and B by 2. So here we have the substitution for cos C by 2 as sine A by 2 plus B by 2. I'll put it over there. And for sine C by 2 I'll say cos A by 2 plus B by 2. So we'll rewrite this term as cos c by 2, that is sine of a by 2 plus b by 2 minus sine of a by 2 minus b by 2. This cos a by 2 minus b by 2 as it is, minus sine c by 2 is cos of a by 2 plus b by 2. And now we will solve this bracket to get cot a by 2. So for numerator and denominator, we'll again apply the formula of factorization. So here I'll use the formula of sin c minus sin d. So we'll get cot c by 2 as it is. Here in the numerator, we will get 2 times cos of a by 2 plus b by 2, that is first term, and the second term is a by 2 minus b by 2, so we'll add it, plus a by 2 minus b by 2 whole upon 2. Second term is sine of a by 2 plus b by 2 minus of second term, that is negative a by 2 and positive b by 2 whole upon 2. Now let's come to the denominator. Here we have cos c minus cos d, factorization formula. So it will be minus 2 sine of a by 2 minus b by 2 plus a by 2 plus b by 2 whole upon 2, and the second term is sine of a by 2 minus b by 2, which is the first angle, and now we'll subtract the second angle, so that is negative a by 2 and negative b by 2 whole upon 2. Now here I can cancel this 2 with 2, b by 2 will be cancelled with negative b by 2, a by 2 with negative a by 2, same here. Now let's see what we get. So it is cot c by 2, in numerator a by 2 plus a by 2 is a upon 2, so here I'll say cos of a upon 2. Here b by 2 and b by 2, that is 2b upon 2, 2 cancel, so we'll get b whole upon 2, that is sine of b upon 2. In the denominator negative sign is there. Here a by 2 is a, so sine a and whole upon 2. Similarly here minus b by 2, so that is sine of minus b upon 2, so minus b by 2. Now we know that sine of minus theta is minus sine theta, so this will become positive. Here I'll say sine a by 2 into sine b by 2, and this negative sign with this negative sign will become positive. Numerator as it is, that is cos a by 2 sine b by 2, and this cot c by 2 term as it is. Now here we can cancel this sine b by 2 with sine b by 2, and we will get cot c by 2, and cos upon sine, that is cot of a by 2, which is our required right hand side. So here we have applied the angles of triangle formulae and we have proved the result. So keep watching videos to learn more about mathematics. Thank you.